So our last one, you're not going to like this one as much because it's abstract, but this is to find the rule for f of g of x. Okay? So just like when we did addition, subtraction, multiplication, division of functions, we had to not only find the rule but also state a domain. We need to do the same thing for this. Okay, specifically for composition of functions, I don't look at the individual functions for domain. I look at the overall composition of functions for the domain. So what I'm going to do is I'm going to create this answer, then I'm going to look at that answer to see what the domain of that thing is. So, with that in mind, if I'm doing f of g of x, that's what I'm doing. Oh, let me just show you this in case they use this notation in your book at some point. That's the same as that. It's an operator. So when you see a plus sign, you know to add. When you see a minus sign, you know to subtract, right? When you see an open circle between two function names, that means to compose the functions. All right, this is the operator for this. So if the book happens to use this notation, in the example problems it didn't, I didn't look through the homework problems that carefully. So in case the book uses the open circle function f, open circle function g, it means the same as this. To me, this is a better way of writing it. It makes more sense to people. So if you see this even in your book, this is first, this is second, f goes outside, g goes inside. Do it in that order. So if you see that notation in your book, use this notation on your paper instead. I think this is more meaningful and useful. Now the difference between this problem and the previous two problems, this doesn't say g of a number, so I can't evaluate g of anything, right? But what I can do, what does g of x equal? Equals x plus 2. So I can take g of x out of the picture and put x plus 2 into the picture. Just basic substitution. G of x and x plus 2 are equivalent to one another. They're the same value. They mean the same thing. So x plus 2 is just as good as g of x, but x plus 2 is more meaningful in the context of this problem. If I see f of anything, it says go up to function f and change x into that anything, right? So now, when I see f of x plus 2, that means to go up to function f, which is this right here. Every x is going to change into x plus 2. So this means 2 parentheses x plus 2 squared minus 3 parentheses x plus 2 plus 1. Now I am squaring x plus 2, I'm multiplying x plus 2 times negative 3, and so on and so forth. So make sure the parentheses are happening there. I'm putting multiple objects in place of one, so replace one with multiple, put parentheses. Next, I need to go ahead and simplify that as much as possible. So let me just do some different colors here. X plus 2 parentheses squared. We've seen this structure many, many times this year. And it's just a binomial squared. It's always going to be the first thing squared, double the product, second thing squared. So x plus 2 squared is x squared plus 4x plus 4. X times x, x squared, 2 times 2, 4. 2 times x times 2 is 4x. Right here, I've got negative 3 being multiplied through this parentheses. That's minus 3x minus 6. Then I got this little plus 1 over here that's just part of the expression that's not really nothing's really happening to it yet. Right. So if you do see some kind of object squared, do that. If you see multiplication, distributive property, do that. Don't try and do all too much at once. Like a lot of people try and get from here right to the final answer all in one step. So be careful that you do things in pieces here. If I distribute this 2 through, now I'm going to get 2x squared plus 8x plus 8. It's kind of following the order of operations here. Powers first, multiplication second, right? Okay, just algebraically we can do what we can do. Then I've still got my minus 3x minus 6 plus 1. And now that everything's simplified out of parentheses, now it's just a matter of combining like terms. So my final answer, I got 2x squared. Positive 8x minus 3x is positive 5x. positive 8 minus 6 is 2, plus 1 is plus 3. So f of g of x is equal to 2x squared plus 5x plus 3. Now, let's consider domain of this thing. Do we see division? Do we see square roots? So the two things that cause restrictions aren't happening in this problem, so the domain would be what? All real numbers. So the domain of f of g of x equals a set of all of x such that x is an element of a set of real numbers. Make sure that you include a domain for any abstract answer. F plus g of x, f minus g of x, f times g of x, f divided by g of x, f of g of x. Anything of x, I need just the answer along with the domain. If it's numerical, there's just a numerical answer. All right? But if there's an of x involved, then make sure you give me a domain also.